Alright, so kule video le ngifuna ukukhuluma nge-matrix addition. Matrix addition, before maybe I dwell on that one, maybe let me recall from what we have already talked about. Okay, we said this is a matrix, and we said immediately in order by 2 by 2. We find 2 by 2 and calculated the number of rows. So 0, 1, 2 rows, then by number of columns 1, 2 columns. Hence we said 2 by 2. And we also said if maybe the matrix ikanje i-order yayo lena yi-2 by 3, lo 2 lo being the number of rows 1, 2 rows, then the 3 lo being the number of columns 1, 2, 3. Hence we said the order of the matrix is to 2 by 3. I'm bringing this because when doing matrix addition, we have to also consider the order of the matrix. So addition will be the same, just like the basic addition, as you know, just like 2 plus 3, you know that is 5, minus 7 plus 5, you know that is minus 2, 2 plus 1 is 3. So this is the basic addition that you know. But then right now we are doing matrix addition. So we're using the same concept and also using the concept of matrix orders, the order of matrix. So firstly, what we have to know is that when doing matrix addition, we have to make sure that the matrix that are being added have the same order. That's what is very important. So when we're adding matrices, if the order of the matrices are not the same, you cannot add those matrices. For instance, if maybe we are saying A plus B, matrix A order is maybe a 2 by 2, just like this matrix, then you try to add with matrix B, which is a 2 by 1 matrix. So the addition here is not possible since the order of the matrix is not the same. This is a 2 by 2 matrix. This is a 2 by 1 matrix. What we have to know, what we have to do, actually, obviously, is to firstly check the order if is the same, and then if you find that the order is not the same, you just realize that the computation, the addition computation, it won't be possible. So let's go straight to adding matrices. So if I give a matrix A 1, 0, 2, 1, and matrix B being 1, 1, negative 1, 0. Okay, so with the question maybe say we should find A plus B. Just like I've already said, firstly we have to check if the order of the matrices are the same or not. So we have 1, 0, 2, 1 plus 1, negative 1, 1, 0. This is a 2 by 2 matrix, the first one. The second one is also a 2 by 2 matrix. So the fact that the order is the same on both matrices, the orders are the same, will continue with matrix addition. So when we are adding matrices, another thing to consider is that your answer will have the same order, just like the matrices. The matrices were 2 by 2 matrices. even my answer will be a 2 by 2 matrix. Here we're going to say, okay, when doing the addition, so elements with corresponding positions are the ones that are being added. Here we start with this one, so we'll say 1. 1 is positioned in row 1, column 1. So when you try to add it with matrix B, you'll also add it with this element, which is also found in row 1, column 1. So we are saying 1 plus 1, you get 2. 0 plus -1, you get -1. 2 plus 1, you get 3. 1 plus 0, you get 1. Okay. Here you realize that what we did here was just basic addition. Although the peak here is that when you add the matrices, you just add the matrices with corresponding, we add elements with corresponding positions. That's what you can note. For instance, we started with this one. So you said 1 plus this one, because those elements are positioned, like they have the same position in their respective matrices. We wouldn't say 1 plus 0. You don't do that. So you just add elements that have the same corresponding position, and also your answer will also be on that set position. I'll make another example. Basically, that's the concept, because it won't matter whether the matrix is a 2 by 2 or 3 by 3 or 1 by 1. If I'm given matrix D is equal to 1 0 1 2 -1 3 0 0 1, and matrix PF 1 0 1 2 1 3 0 1 0, and then we have to find D plus F. Okay, first we have to check, is this what is the order of this matrix? We find that this is a 3 by 3. How about this one? This one is also a 3 by 3. Okay, so we are good so far. The order of the matrices are the same. So how about your answer? So your answer will also be 3 by 3. Okay. How do you go about? Elements with the same position are being added together, and their answer is also that position. We start with 1 plus 1. We get 2. 0 plus 0 gets 0. 1 plus 1 get 2. 2 plus 2 4. -1 plus 1 0. 3 plus 3 6. 0 plus 0 0. 0 plus 1 1. 1 plus 0 1. Hence this is the answer. Okay, so even if we do subtraction, it's just the same thing. For instance, if the question here was to find D minus F, you're going to do the same thing. Firstly, you consider whether this is a 3 by 3 matrix, whether the order of the matrices are the same or not. In this case, we found earlier that these matrices are both 3 by 3 matrices. So we're also going to say 1 minus 1, and that's 0. 0 minus 0, that's 0. 1 minus 1, that's 0 again. 2 minus 2, that's 0. Negative 1 minus 1, that's negative 2. 3 minus 3, that's 0. 0 minus 0, it's 0. 0 minus 1 is negative 1. 1 minus 0, that's 1. So this is also a 3 by 3 matrix. That's your answer, basically, this one. So that's how you compute the addition and subtraction of matrices. What I said here, I recalled that what's the order of a matrix, because you needed to use that concept when trying to add matrices. Then we also emphasize on the fact that when you want to do matrix addition, you have to first check whether the matrices have the same order. Then if they have the same order, the matrix addition is hence possible. Whereas if they don't have the same order, you can't try to add matrices who don't have the same order. Okay, maybe let me try to do this. Maybe to bring some light. 2 1 0 1, and we have B 1 1. If maybe someone can say compute A plus B, so you say 2 1 0 1 plus 1 1. Remember, I said when doing the addition, you add matrices of the same order. Matrices, you add elements with the same position in their respective matrices. We got this 2 by 2 matrix. You got this 1 by 2 matrix. Okay, this value, the 2, is found in row 1, column 1. Even this 1 is also found in row 1, column 1. Then we say 2 plus 1, you get 3. Then 1 plus 1, you get 2. How about this 0? 0 is found in column 2, row 1. But then in matrix B, there's no element that correspond to row 2, column 1. Hence, the addition won't be possible. So that's why we say the matrix's orders should be the same. So another thing, when doing matrix addition, it doesn't matter whether you got 2 matrices or 3 matrices or 5 matrices, because maybe a question can say compute 2 1 0 1 plus 3 1 0 0 plus 1 1 1 1. I'm making an example here, nothing to worry about. All these matrices are 2 by 2 matrices, and then your answer will also be a 2 by 2 matrix. And if you compute here, same concept, elements with the same corresponding positions are being added together. We have 2 plus 3 plus 1, that's 6. Then again, 1 plus 1 plus 1, that's 3. 0 plus 0 plus 1, that's 1. 1 plus 0 plus 1, that's 2. So that's how you find your answer. Okay, even if maybe here you had a minus just like this, you're going to say 2 plus 3, that's 5. Then minus 1, that's 4. Get 4. 1 plus 1, that's 2. Minus 1, no, that's a 1. 0 plus 0, it's a 0. Minus 1, it's a negative 1. 1 plus 0, that's a 1. Minus 1, you get 0. Yeah, that's how you do matrix addition and matrix subtraction.